Okay, all right. So this will be your first lesson of Form 5 Physics. So it's natural for me to brief you through all the topics in your Form 5 syllabus. Okay, let's do a recap on Form 4. Okay, Form 4. For Form 4 Physics, what do we have? We have measurement, we have force, we have forces and motion, right? Forces and motion, part 1. And then we have gravitation. After gravitation, we have
Heat.
heat. Yes, you're right. Heat. And then we have waves.
Then
And
light.
then light. Okay, so these are all your Form 4 topics. For Form 5, do you know what's the name of the first topic?
Forces and motion 2.
Exactly. Forces and motion 2. So what does this mean? It means whatever you learn in Form 4 Chapter 2, okay, whatever you learn in Part 1, you must remember until your Form 5. Okay? You must remember because everything that you do in this chapter, you need to apply what you learn in this chapter. Do you understand?
Yeah.
Okay, all right. And the second chapter for Form 5 will be pressure. Now, if you remember from your Form 2, pressure is defined as the perpendicular force acting on a unit area of a surface. So pressure is also somehow related to force. So you also need to remember from your force all the way to pressure, okay? And then afterwards, chapter 3, you have electricity. Okay, electricity. Afterwards, you have electromagnetism. Hello. Okay. All right. Okay. All right. Electromagnetism and
Hello, philosophers.
electronics. Okay, electronics. So what can you see from these 3 chapters? You can see that they have the word electri, okay? So all these are related to electrons, okay? It means that whatever you learn in
I also see it.
electricity. Excuse me, what? What do you say?
Nothing.
All right, okay. Whatever you learn in electricity, you must remember for your electromagnetism. And whatever you learn in electricity and electromagnetism, you must remember until your electronics. Okay? Other chapters, after you learn already, you forget, never mind. But then after you learn this, you must remember until this and until this. So you have a lot of things to remember for these 3 chapters. These 3 chapters, they are actually one chapter, but the chapter is very long, so they split it into 3 parts. Do you understand? Is that right? Okay. And then next, you have nuclear physics. Nuclear physics, I would say, is a very fun chapter. Why is it very fun? Is because you actually get to learn more interesting things. Okay, nuclear physics. Okay, after you have quantum physics. Okay, these are the more modern topics lah. Okay, that are more modern. So all these are like very the rest are all very classical topics, but then nuclear physics, quantum physics, these are something very new. And it is actually for our future, okay? As you can see, we all know that fossil fuel is a non-renewable energy and a non-sustainable energy. One day we'll run out of fossil fuel, right? So we are trying to discover ways to create electricity without the use of fossil fuel, right? Since the past, we have all been using fossil fuel, petroleum, natural gas, coal. We use it to burn stuff. We use it for our cooking. We use it for our cars, vehicles. All these, we all use fossil fuel to generate electricity. We all use fossil fuel, but one day fossil fuel will run out, and we don't want that to happen. So, and if that happens, we won't have electricity forever unless we discover another way to create electricity. That's why we we started to use solar power. We started to use what's that? Wind. Okay, we started to use wind. We started to use hydroelectricity. We started using nuclear energy. So what is this nuclear energy? You learn that in nuclear physics. And in this chapter of nuclear physics, I'll say it's very interesting because you actually get to learn how to make a bomb. You get to learn how to make a bomb. The theory part of how to make a bomb. Okay, materials not provided lah. I won't provide you the material to make a bomb. I'll teach you the theory of how a bomb works. Okay, it's a very interesting topic. And then afterwards for quantum physics. Okay, quantum physics is an entirely very new topic, even for your SPM syllabus. Okay, your seniors, okay, 1 year older than you, they are the first people to learn quantum physics in SPM. Okay, during my year, we don't have quantum physics. We learn quantum physics in college, but then for the new SPM syllabus, they start to have quantum physics. So it's a very interesting topic, and you learn. I would say it's one of the toughest topics for your syllabus. That's why they put it as the last chapter. Yeah, excuse me.
The hardest one is to remember a lot of things.
Which one?
The last chapter.
No. Quantum physics, you don't need to remember anything. You just need to understand. What you need to remember, actually, physics, not much memorizing. You don't really have to memorize anything for physics compared to biology. Biology memorize more, right?
Yeah.
Biology, everything also need to remember, right? Different bones, what's the name of that bone, different organelle, what's the name of the organelle, what's the function, all that you need to remember. And there's no theory, no explanation. The teacher say what means what, you memorize. Okay, chemistry also same, right? Chemistry, you need to memorize the electrochemical series, you need to remember all that stuff. So
chemistry is worse. You need to understand and also need to memorize so anyone can apply.
So physics is very logical subject. You just need to understand. And physics, more calculation. And theory, very easy to understand. No memorizing. Okay? No need memorize. You just calculate. You look at the formula paper, you take your calculator, you calculate. That's all. Physics is very simple. All right. So, okay, for Zekai, okay, you just came in, right? So, okay, all right. So you just came in. So I want you to know one thing is that for your Form 4, okay, these are the topics you learn in your Form 4, and these are topics that you learn in your Form 5. Whatever you learn in your forces and motion part 1, you must remember all the way until this. Okay, today I'm going to teach you forces and motion 2. Whatever you learn in your Form 4, you must remember until your Form 5, because whatever you're going to do today, you're going to apply what you learned in Form 4. Same goes for these 3 chapters.
They two got connect one.
Yes, it's connected. You get from the name of the chapter, you can see it's part 1 and part 2. So obviously it's connected. You will apply what you learn. And for these 3 chapters, they are also connected. They are actually one chapter, but then they split into 3 chapters, 3 parts, because it's too long. Okay, so these 3 are connected. And forces and motion, part 1, part 2, they are actually connected. Okay, and about your notes, because just now you're late. So what I want to let you know is that you will receive your notes next week. You will receive a hard copy notes next week. And for today, because you won't be having your notes, so you don't have to write down anything. All you have to do is listen to me and enjoy my lesson. Whatever I write down, feel free to screenshot. Okay, feel free to screenshot. And when you receive the hard copy, all you need to do is write it back into the book. Do you understand? Okay, all right.
Okay.
So, okay. All right, so let's start our Form 5 topic. Okay, so the first part of the chapter, what you will learn is resultant force. Okay, so what exactly is this resultant force? Resultant force got another name. Okay, resultant force is also called net force. Okay, just like your net flow of heat, okay, you will also have a net force. Okay, so resultant force, also called net force, is a single force equal to the vector sum of all forces applied. What is a vector? What is a vector?
Is vector a direction?
Vector is actually a quantity with magnitude and direction. You learn it in
Oh yeah.
physics. You learn it in maths, right? Maths. Okay. So if you learn vector in Form 4 physics, you learn vector in your Form 4 maths, I'm sure you are expert of the meaning of vector already. So whatever I'm going to show you today, you confirm will understand one. Confirm. If you take
It's
maths,
just
you
the same
confirm will
thing.
understand. Huh?
It's just the same thing.
They are the same thing. Exactly the same thing. It's just that in maths, you learn vector without any unit, without any quantity. You just learn like something like let's say here you have a vector, and then
The vector of AD equals to
yeah, okay, let's say here you have one vector, here you have one vector. What's the sum of these two vectors? The sum of these two vectors is this one, like the sum of these two vectors will be this one. You understand? Right, you learned that in your maths already.
yes, but I'm not good in that chapter.
It's okay. Today I'll make sure you understand that chapter. Okay, so two forces acting on an object in the same direction. So what will happen when two forces act on an object in the same direction? Okay, so let's say over here. Okay, over here, I have an object. Over here I have an object. Let me try to change the color, make it look nicer. Okay, wait. Let me disable the annotation so you guys don't draw on my screen. Who is that? Who draw on my screen just now? Who write on my screen? Hey, so naughty.
Damn it, I cannot delete it.
Okay, I disabled the annotation already. Alright. Okay, it's alright. So it's you. Hi. Okay. So let's say over here, I have an object. Okay. You don't have to write anything down. Okay. When I finish this, you screenshot and then you just write it back into your notes. Okay. So over here, I have an object. Let's say I pull this object with a force with of let's say I pull with 10 newtons. Okay, I pull this object with 10 newtons. So this object is pulled by a force of 10 newton. But let's say you want to make this object move faster. What are you gonna do? You pull with another force, or you ask two people to pull the same object together, right? In the same direction. So add another force here. Okay, let's say this force is 15 newtons. So what is the total force? What is the total force acting on this object right now?
25.
Exactly, 25 newtons.
But is the 15 Newton an additional force?
Yes, it's an additional. Okay, resultant force. Okay, 25 newtons is the resultant force. Oops, different color. Okay, 25 newtons is the resultant force. Resultant force is basically like the total force acting on the object. Okay, what will bring the result for the object? Okay, if you pull that object with two forces, one is 10 newton, one is 15 newton, what is the result? The object will move with a force of 25 newton. Understand?
So where's the 15 Newton from?
No, this means like let's say if you don't understand, let's say here got one object. Okay, you and your friend pull together. Okay, with a rope attached to the object. Okay, you and your friend pull the object together. So the object, let's say you pull with 10 newton because you are weak. Your friend is strong. Your friend pull with 15 newton. So that object will move in this direction with 25 newtons. Am I right?
Yes.
Does that make sense to you?
I think so. So if I don't have my friend there, would the resultant force just be 10 Newton?
Exactly. Resultant force is like the total force acting on the object. Do you understand?
Oh, like the result.
Yes, the result. Exactly. The result. Understand or not, everyone?
Yeah, I understand now.
What about the rest? Okay, good. All right. So you all understand what is resultant force. So you can take a screenshot of this. Okay, you can take a screenshot. Okay. Done?
Yeah.
Okay. So let me erase this. Okay. Let's say when two forces act on an object in the opposite direction, what does it mean? Let's say you pull with 10 newtons in this direction. Your friend pull in this direction. Oops. Your friend pull in this direction to the left. You pull to the right, your friend pull to the left with 50 newton. What is the resultant force?
Uh, 5 Newton.
5 newton in which direction? Remember, force is a vector quantity, and resultant force is the total vector sum. So we must always state the direction when we are talking about vector quantity.
Oh, then negative 5 Newton.
Okay, you can say negative 5 newton if you want to take positive as your right, negative as your left, but you can just say the magnitude 5 newtons to the left. Okay, the resultant force.
So I cannot write.
Okay, 5 newtons to the left. Do you understand?
So I cannot write in the negative form.
You can. I mean, but if the question asks you to state the magnitude and direction of the force, later when we do the exercise, you understand what I'm talking about, lah.
Okay.
Okay, you have to state, let's say 5 newtons to the left. Do you understand?
I understand.
Okay. So let's say, okay, a simple example for this is, let's say tug of war. Do you know what is tug of war?
Yeah.
Okay, tug of war. One side, both sides are pulling forces in opposite directions. One side will be stronger than the other, and then the entire system will be pulled towards the direction of the stronger force. So this is what is happening in this case. You have an object, you pull the object with 10 newtons to the right and 15 newtons to the left. What will happen to this object is the object will be pulled, is equivalent to, like, the object is being pulled by a force of 5 newton to the left. That's the meaning of resultant force.
So if both sides have the same force, that means the object will not move.
Depending on whether the object, okay, so when both sides are pulling with the same force, the resultant force is 0, right?
Yeah.
When the resultant force is 0, does that mean the object is not moving?
Yes.
No. It means that object is not accelerating. Okay? F equals to ma. If resultant force is 0, if F equals to 0, your acceleration will be 0 because the mass cannot be 0. So the acceleration will be 0. If the acceleration is 0, the object will have there are two possibilities. Either the object is stationary, which means not moving, or the object is moving with constant velocity.
So if it means 0 acceleration, that means it's stationary?
No. 0 acceleration means there is no change in velocity. It is not becoming faster, it is not becoming slower. So not becoming faster or slower can only mean two things. Either the object is not moving or the object is moving at the same speed.
So basically, it goes to this side and that side again.
Okay, no. Okay, I'll show you. Let's say you have a car. Okay, you have a car. Okay, just excuse my ugly car lah. Okay, this is a car. Okay, let's say the car moves in, let's say the car moves at a constant velocity. Okay, the car is not accelerating at all. The car moves with a constant velocity. Okay, constant velocity. It means that the resultant force acting on this car is 0. Why? It's because when the car is moving forward, okay, let's say to the right is forward. The car is moving forward. Is there a force? Is there a forward force?
What does it mean?
If a car is moving forward, does that mean that the car is using a force to go forward?
Yes.
Yes, exactly. The car is moving forward with a force. So this force, we call it as an engine thrust. Okay, there's a force because of the engine thrust. So there is a forward force, but then if there's a force, it means there must be an acceleration. Am I right?
Yeah.
F equals to ma. If there is a force, there must be an acceleration. But over here, there is no acceleration. Why is there no acceleration? Because the resultant force is 0. Why resultant force 0? There is another force in the opposite direction. Do you know that? If the car is moving at constant velocity, there will be another force in the opposite direction that will be at the same magnitude as the force that it is going forward. This is what we call as a drag. Okay, it's friction, air resistance. Okay, like the car and the road surface, there is friction. So friction will actually give a force in the opposite direction to not let the car accelerate. Do you understand?
I understand.
Okay, so because the force going forward and the force that is opposing it, that is going backwards, okay, both of these same magnitude, then the car will move at constant velocity. So not necessary when resultant force is 0, the object will be stationary. Do you know that? Okay, understand already? Okay, understand already, right?
Understand.
Okay, what about everyone else? Do you have any questions?
Oh yeah, this is also a different case where it depends on the material of the object. Yeah, if we pull in the same direction, the different direction, then the object will break.
Okay. About objects breaking, you will also learn it in this chapter. At the end of this chapter, the final topic of this chapter, I'll teach you elasticity. Okay, when an object exceeds a breaking point, the object will break. Okay, every material, they have a different breaking point. And then when the force you exert on the object exceeds the breaking point, the object will break. Or when you exceed a certain elastic limit, the object will deform. For example, rubber band. You pull, you'll go back to original shape. You pull, you go back to original shape. But when you pull with a greater force, you realize it cannot go back to its original shape. It becomes longer a bit already, right? I don't know you try before or not lah, but then that's what will happen. Right? I'm sure you tried before and you play rubber band, you pull. Every time you pull, you'll go back to original shape. But when you pull too hard, not hard until the rubber band break lah, but when you pull too hard, you realize that before it breaks, or the rubber band becomes longer. It cannot go back to its original shape already. It becomes not so elastic already, right?
Yeah.
Yeah, so that one you will learn later. You will learn later at the end of this chapter. I'll teach you that. So you don't worry about the object breaking or not. Okay. Right now, you just want to learn the resultant force. Is that okay?
Okay, understand.
Okay. All right. Okay. You can screenshot this. Okay. Remember, after you screenshot, after you receive your hard copy notes, copy it in your notes. Okay. Okay. Can. All right. So moving on. Two forces acting on an object perpendicular to each other. What does perpendicular mean? What does perpendicular mean?
90 degrees.
Exactly, 90 degrees. So when two objects, they are perpendicular to each other. Okay, let's say this is the center. Different color. Okay, you have two forces. Perpendicular to each other. Okay, so let's say this force is 4 Newton. This force is 3 Newton. Okay, so what will be the resultant force? You learn this in your MS already. What's the resultant force?
One.
No. you see, okay, when you have this, okay, when you have an object like this, you pull with a force in this direction, okay, to the right, and then you pull with a force in the direction upwards. What will happen is the object will go in this direction, right?
Linearly.
Right. The force, the object will move in this direction. So, if the angle here does not exceed 90 degrees, okay, if it does not exceed 90 degrees, the resultant force will always be larger than these two forces, right?
Yes.
Okay, so what will happen is, okay, so it's a vector quantity. So the first two parts of this resultant force, okay, in the same direction and opposite direction, you already learn to find the magnitude. Okay, you learn how to find the magnitude. If it's same direction, you add them together. If it's same direction, add them together, the direction will be same direction. And if it's opposite direction, the magnitude will be the larger one minus the smaller one, and the direction will be in the direction of the greater force. Right? So I'll teach you how to calculate the resultant force. Okay, the resultant force. Okay, what will happen is you will get a resultant force. You get a resultant force over here in this direction. Let me use a different color. Let me use what color? Let me use this color. It's bright. Okay. This will be your resultant force. The resultant force will be here in this direction. Is that all right? Understand, right?
What's the actual value of the resultant force?
Okay, what is the value of the resultant force? So now let's apply logic. So this force, okay, so what we can do is we put them into a triangle like this. Okay, we make it into a triangle because as you can see, it's clearly a triangle over here. So we apply logic here. To the right 3 Newton, upwards 4 Newton. Resultant force, you use your Pythagoras theorem. Okay, your Pythagorean theorem. Okay, the resultant force will be the square of 3 Newtons plus the square of 4 Newtons, and then you find the square root of that sum, you will get 5 Newtons. What is the direction?
Increasing linearly.
Okay, what's the direction? The direction over here, you have an angle. Okay, the angle we'll call the angle theta. So what is the direction? Okay, the direction, okay, you find is the angle from the horizontal. Okay, how do you find the angle? Okay, can anyone tell me how to find the angle? What mathematical concept are you going to use?
Sine.
Technically you can use all. So we are actually using trigonometry. If you're using sine, you use the opposite and the hypotenuse. If you're using cosine, you're using the adjacent and the hypotenuse. If you're using tangent, which I like to use tangent because the question gives you the adjacent and the opposite. Okay, over here, imagine there's another force of 4 Newton. Okay. That will be the resultant force. Okay, so okay, so the angle will be the tangent, because the opposite of this angle is this part. This part is the vertical force. Okay, opposite 4 Newton over the adjacent. The adjacent is the horizontal part, 3 Newton. So you just arc tangent. Okay, the angle will always be the arc tangent of the vertical force over the horizontal force. Okay. then arctangent 4/3, it should be 53.1, right? 53.1 degrees. Okay or not? Do you understand?
Yeah, I'm using my other method.
You're using what? Sine? Cosine?
The MX method, the sine one.
Oh, okay. Can. Any method is fine. Okay, this is the method that I like to use. So, what is the magnitude? The magnitude is 5 newtons. What's the direction? The direction is 53.1 degrees from the horizontal. So, the question always like to ask you, state the magnitude and direction of the resultant force. So you say the resultant force is 5 newtons at 53.1 degrees from the horizontal or to the horizontal. Do you understand?
Yes.
Okay. What about everyone else? Okay, I assume all of you okay, no problem. So you can screenshot this, okay? Screenshot this. All right. Let me know after you're done. Done?
Yep.
Okay, everyone screenshot already, okay. So now let's get to the hard part of this chapter. Not hard part of this chapter. Actually, this subtopic of resultant force, there's only 4 parts. So this is the tougher part one. When both forces are neither parallel nor perpendicular to each other. So if it's same direction or opposite direction, is parallel. But if it's not parallel, not perpendicular, how do we find the force? Okay. Let's say, okay, hold up. Let's say find an example. Okay. Instead of giving magnitudes, I'll just show you how I do it. Okay, so let's say you have a force here. And a force here. So I'll be labeling this as F1, this as F2. So there are 2 forces. Okay. And then this angle, I'll label this angle as alpha.
Why is it labeled alpha?
I want to label alpha. Okay, you can use any symbol you want. Okay, not necessarily have to be alpha. Okay, I want to use alpha. Okay, so what is triangle of forces? Triangle of forces means that you have to redraw this. So this is the force acting on an object. Let's say here you have an object. Okay, here you have an object. You are pulling with a force in this direction and this direction. You're acting 2 forces on that object. So what will be the resultant force of that object? So very simple. You have to redraw the component of forces into a triangle. That's why it's called the triangle of forces method. So you redraw until it becomes like this. Oops, the arrow. Okay, this is your F1, this is your F2, and the angle here, okay, the angle here is alpha. Okay, so and then right now you want to make a triangle. So what you're going to do is you're going to draw the resultant force by connecting these two forces and form a triangle. So this is your resultant force. This will be your resultant force. Resultant force. Okay.
How do we
Then
know,
this will be
how
your
do we know
angle.
the force is coming from the other
Huh?
side?
What?
How do we know the force is coming from the other side?
What do you mean from the other side?
F1. Because in the first picture, we see F1 from the bottom, but then when we redraw the...
Oh, okay. So we know that the resultant force will be in between F1 and F2. This will be your resultant force. But we don't know what is the magnitude of the resultant force or the direction of the resultant force. We know it's in between these two, right? We know it's in between these two. So what we are going to do is we're gonna let's say the force over here. Let's say the force is 3 Newton. Over here is 4 Newton. What you're gonna do is you're gonna draw a scale that is let's say you put 1 cm equals to 1 cm. Okay, the ratio 1 cm is 1 Newton. So you're gonna draw a triangle. This line will be 3 centimeters. And then you draw this line as 4 centimeters. And then the angle here will be the angle here. Okay, you're basically moving this force to be here. Okay, once you move it here, you draw a line connecting these two. Okay, you draw a line connecting it. And then once you draw that line, okay, you know that over here is 3 cm, here is 4 cm, right? And then when you draw the line, okay, when you draw the line, what will happen is you're gonna measure it with a ruler, the length of the line, and that length of the line you convert it, because you measure in cm, you convert it back to Newton. That will be the resultant force, okay, the magnitude of the resultant force. Is that okay? And then the angle over here, okay, from the resultant force to the horizontal force, that will be the direction, okay, theta. Are you clear?
I don't really understand.
It's all right. Okay, you screenshot this. Later, when we do the exercise, you know what I'm trying to say. Okay, I'll do the exercises with you so you understand. Is that all right?
Yes.
Anna? Okay, so you screenshot this. Done?
Yes.
Okay, good. All right, so I'm gonna erase this. And then what if we have the same scenario here? Instead of using the triangle of forces method, we can also use the parallelogram of forces method. So we're gonna, what is a parallelogram? A parallelogram is basically the same thing. Okay. Okay, you have F1 here. We're gonna redraw it. Okay, we have F1. We have F1 here and F2 here. Okay, F1 and F2. And the angle here is alpha. Alpha. Okay, and what if we add a parallel line here? Okay, what if we add a parallel line? Okay, how do you draw this parallel line? So you're gonna take a compass. Okay, you're gonna take a compass the sharp point of the compass, you're going to put the sharp point of the compass here, the pencil here, and then what you're going to do is you're going to draw an arc here. Okay, you are going to draw an arc over here. Here. Okay, you're going to draw an arc here. About here. Here. Like that. Okay. And then at this point, sorry, okay. No, sorry. Okay. You're gonna put the sharp point of the compass over here. Okay. Sharp point of compass here. You're gonna put the pencil here. So that is the length. Okay. You fix the length, and then you put the sharp point here again, and then you draw an arc here. Yeah, okay. You draw the arc here. Okay. After that, you're gonna put the sharp point here again. You place your pencil here, so you have the fixed length, and then you put the sharp point here, and then you draw an arc here. Okay, understand?
And so we'll get a very accurate point.
Okay. I wouldn't say it accurate. So what you're gonna do is you are going to draw a line, and this line will be parallel. It's not really parallel. Hold up. Sorry, because I'm not using a ruler to draw. Okay, I'm drawing on my screen, so it won't be parallel. So let me try my best to make it look parallel. So you'll get a line that is parallel, and another line parallel. Okay, if you use your compass to draw, you should get a parallel line. You should be able to get a parallel line. Right, using your compasses. Okay, so this line is parallel to this line, right? This line is parallel to this line, and this line is parallel to this line. So this is a parallelogram, okay? In your mathematics, I'm sure you learn how to draw a parallelogram already. So that is the parallelogram. And then what you're going to do is you're going to use your ruler, okay? You're going to draw a diagonal line to join that corner to the other corner. This will be your resultant force. And this will be your angle. Okay, you draw according to scale. Let's say the question gives you in newtons, you draw according to scale in centimeters. You get a very close, answer to the actual answer. Do you understand this?
So with this method, we're creating the parallel angle. So we get something like a rhombus here.
Okay, so what is happening is this is not a force. This is not a force. This is something that does not exist, but it's imaginary, because this is the force and this is the force. But if you imagine there's another parallel line here and another parallel line here, and these two parallel lines intersect at this point, you draw a line. Okay, you draw a line from the point where the force is acted on to this point. Okay, you draw a line diagonal to the parallelogram that you draw. The length of this force, the ratio of that length to this length will be the ratio of the resultant force to this force. Do you understand? The ratio of the length will be equal to the ratio of the force. Is that clear?
Yes.
Okay, so you screenshot this first. Screenshot that. All right, done. All right, done now. Okay.
Done.
Okay, everyone okay? Give me a reaction if you're okay with this. Okay. What about the rest? Okay. Zekai, what about you? If you have any questions, feel free to ask right now. if you have any questions, feel free to ask. It can be any question, any type of question about this. You want to ask? Okay, I'll try my best to answer.
About the triangle of forces method.
Yeah.
How does it work again? How is it?
What do you mean
how
Okay, so you see over here, by drawing a parallelogram, I'm drawing another a component here that is parallel to this, right?
we are fitting the we are completing the shape.
Yeah, we're trying to make a parallelogram, and then we draw a line diagonal to the parallelogram. Triangle of forces work the same way. What you're doing is you're actually drawing another line parallel to this line, and then okay, as you can see over here, instead of drawing a parallelogram, you can see that over here, let me use a different color. Let me use pink. This is the triangle, right? This is a triangle. Right? The pink color one, what I draw is a triangle. So triangle of forces, basically, we don't need to draw this parallel line. We don't need to draw this parallel line. What we're doing is we're straight away taking this, we put over here. Once we put over there, we draw a triangle. We draw the triangle, we measure the length of that side of the triangle, that will be the resultant force. That is what why we use the triangle of forces. Okay, that's how we use the triangle of forces. Understand? Understand? Don't understand? Let me know.
I still don't really understand.
It's okay. If you don't understand, when we do the exercises, I need you to draw the actual triangle and the actual parallelogram yourself. Then you will understand. Okay, anyone got any other question? Okay, so Kai Huang in the chat. Okay, Kai Huang, actually don't just send direct messages to me. Don't send direct messages to me. Send it to everyone so that everyone can see the question, because this is a good question. I want everyone to know what you ask. Okay, so next time when you got any message, just don't need direct message me. Just send to everyone so everyone know what you're asking. Okay, so Kai Huang asked, actually, what is the use of finding the angle? So that angle is actually the direction of the resultant force. Okay, the direction of the resultant force from the horizontal. For example, let's say over here you have a let's say your car breakdown. Your car breakdown. Okay, your car, let's say I draw the car as a square shape lah. Okay, the car breakdown. You want to pull your car. So you pull a car here. You pull a car with a force in this direction, and then your friend come and help you. Your friend pull in this direction. The car will move in this direction. Okay, understand or not this part? You pull in this direction. Your friend pull in this direction. The car will move in this direction. And in what direction the car will move? From, let's say, we find the angle here. So we know the direction that the car is moving from your direction. What is the direction from your direction that the car will move? Are you clear? Okay, so this is very important if you want to be an engineer. Okay, this is important if you want to be an engineer. An engineer, of course, you need to understand how all these forces work. Okay, or how all the forces will work in equilibrium, what direction that forces will act, and all that stuff. Okay, this is important for engineering, and not just engineering. Basically, anything that you want to do that is related to mechanics. Mechanics means the branch of physics that deals with movement. Okay, kinetics, forces, all these. Okay, mechanics. So what any okay, since this is our first Form 5 lesson and I don't really know you all well, let's introduce ourselves. Okay, why not you all tell me? So I'm gonna go according to your names over here. Okay, you tell me why you're taking physics, or what's your dream? What job do you want to have in the future, or what course do you want to study in your future? If you don't know, yeah. Or you can tell me, okay, let's introduce ourselves, okay? Tell me your name, tell me, even though I'm gonna call your name. So tell me your name, tell me what school are you from, or tell me where are you from, like which area, and tell me what course do you want to study or what job do you want to have in the future. Okay, so I'm gonna go according to your name. Okay, starting with Kai Huang. Why don't you introduce yourself first?
Uh, my name is Ang Kai Huang. You can call me Kai Huang.
Okay.
I'm from Methodist Boys School.
MBS Methodist Boys School, the one at KL, right?
KL one.
Outside the Maba Stadium, right?
I got stadium one. Yeah.
Okay. I know that school. The one outside the big basketball stadium, right?
Yeah, correct.
Yeah, okay. I know. I've been to your school many times.
Oh, okay.
I've been to your school many times. Yeah, for like other events. Yeah. All right. Okay. Why are you taking physics? What job do you want to have, or what course do you want to study?
Actually, I don't know. Because like I chose science stream because like it can give you a variety of choices like in the future rather than taking an art stream. So I just take science stream.
Are you taking any additional subjects
No.
like accounting? No. So you're not taking accounting, not taking economics.
Wait, but because my school is like I take sub, I didn't take pure. I didn't take biology, but I took physics and chemistry.
Okay.
And then I have to take accounts and economics.
Oh, okay. So right now you have a lot of choices. Okay, but you can't be a doctor. Okay, because you're not taking biology, you can't be a doctor. But you can be an engineer. Okay, as long as you have chemistry and physics, you can be an engineer. If you want to be an accountant, you can be an accountant. You want to study business, you already know economics. So actually, your choice is not bad. Yeah, I see. Okay, all right. So you like doing mathematics, right?
Actually no.
But you're taking physics, you're taking accounting. You must like mathematics, or else like in your future career you will suffer lah. All right. Okay. All right. Thank you, Kai Huang. What about Zekai? Do you want to introduce yourself? I saw you turning on your camera. All right. Don't be shy. All right. Introduce yourself. No. All right. Never mind. Thank you. What about Philotus?
Hi everyone, I am I'm Floated Guang. Hey,
What? Okay, it's okay. You want to introduce yourself? Is it?
or is he having technical issues?
Okay, never mind. All right, Philotus, you go on.
I'm from Selangor of Sungai Buloh, and I go to the SMK BRP school, which is Bukit Brahmaputra.
Okay.
Yeah, the physics are particularly one of my favorite subject. One of the few subjects I like. Maybe the reason why I can understand easily because of maths. I'm not that good in maths. I'm just like I like maths. I do a lot of maths, but I'm still not the best in it. I like physics because it's like lets me understand a lot of like logical things easily. More than it doesn't require you to like memorize things. It's more everything's all in physics is theory like that.
Exactly.
So I haven't thought of what I actually want to do in the future. I've never considered that because I'm still young. I I haven't thought of what I would be doing in the future. So I just took the science stream because I like biology and physics.
Oh, okay. Okay. All right. Thank you, Flotis. Okay, so all of you have introduced yourselves, but I haven't introduced myself, and I've been teaching you for more than 1 month, but you still don't really know me. So let me introduce myself. Okay, I'm Benison, right? And I'm 19 years old this year. Okay, I'm 19 years old this year. Do you guys know my age actually?
No, now I
No.
know. I
Now
thought
you know.
you were in your actually the look from your face looks like late early 20s.
Okay. It means I look mature, right? Right. Thank you. Okay, so I'm taking my college right now lah. So I'm 19 years old this year. I'm also from Selangor. Okay, I'm from Kota Damansara. Okay, Petaling Jaya.
Challenge.
Yeah, from Petaling Jaya. My school is also in Petaling Jaya, Catholic high school, if you know. All right. So that's why actually I've been to Kai Huang School, okay, because like there's like those events, right? Christian events. So, my my dream is to become a physicist. So I'm gonna study physics. Right? My whole life is dedicated to physics. I live and breathe physics. So that's
How are
why
you?
I'm 19. Yeah. Okay, so I love physics. That's why I'm teaching you physics right now. I'm good in physics and maths and at maths and all that stuff. So I also teach at maths. But then mainly in physics, because I want to be a physicist. I'm gonna be a physics professor. I'm gonna lecture in universities. I'll be doing scientific research and hope I can have a scientific breakthrough, discover a scientific breakthrough in physics. So that's why I'm teaching physics right now to gain work experience and also to educate the younger generation about physics. So why do I love physics is because physics is actually the most logical form of knowledge. Everything works because of physics, because physics is the
I think
study.
biology better in logic.
No. Hear me out. Shh. Listen to me. Listen to me. Right. So physics, okay, physics is actually how everything in the universe works, because physics is the study of the fundamental laws of everything in the universe. Okay? Everything works because of physics. You want to understand why something happened? It's because of physics. See, biology is actually applied chemistry. What everything you learn in biology is because of the chemists. They discovered something. They discovered chemical reactions in the body. That's why biology, they don't know why that thing happened. They don't know. The chemical, the chemists tell them the chemical reaction is like that, or they just memorize and then they tell you. So biology, you actually only study the chemical reactions in the body. So biology is applied chemistry, but chemistry is actually applied physics. Everything you learn in chemistry was discovered by physicists. They only
Oh yeah, I
apply
gotta
what
take
the
something.
physicists tell them. Sure, go ahead. So chemistry is actually applied physics. You learn that positive in chemistry, you learn positive attract negative. Chemistry, your teacher only tell you, your chemistry teacher tell you positive attract negative. Your teacher don't know why positive attract negative. Physics, you learn because of the electric forces. Right. After you learn that, positive will attract negative. You learn that in physics.
That's why
Chemistry. Right. And then
that's why
you know,
mathematics
yeah.
and physics they are
And then
called the laws of the
yeah,
universe.
it's the law of the universe. Everything must follow this law. Physics say yes means yes, no means no. Chemistry, no. Chemistry, many rules, many laws. All these laws and rules got so many exceptions. Right? Example, you learn your what?
We are not
You,
Martin Teo.
hey, don't tell him I say this. Don't tell him I say chemistry not good. Quiet. Quiet. I'm gonna mute you. So in chemistry, you learn metal, non-metal, form ionic bond. No lah. When you go college, you learn more you learn more chemistry. You know, no. Got many exceptions. No, not every time metal and non-metal form ionic. Can form covalent. Afterwards, you learn that. You learn. Your teacher tell you octet electron arrangement, right? Stable, right? No lah. Who say it must be stable? No, that is until the second shell only. Shh. No. No, Mr. Martin here. No. So chemistry, many exceptions. So chemistry cannot explain why. Physics can explain everything. Everything in the universe. Everything follow the same physics law. So everything happened because of physics. You want to know why you are able to hear me speaking right now? Physics explain that in waves. Right? Sound waves travel right through a medium. Why you are able to see me is because of light. Even why there are chemical reactions is because of physics. And for your information, okay, so physics is everything about particles, molecules, and all that. So it's all about atoms as the basic units. And if you remember from your atomic model, okay, there are so many. So if you remember, there's one topic in chemistry about the development of the atomic model, right? All the scientists' contribution. Let me tell you what, all those scientists, they are actually physicists. Physicists were the one who discovered atoms. Physicists were the one who discovered electrons, protons, neutrons, and all that. Physicists who are the ones who explain the atomic model. So physics is the law of the universe. Everything works because of physics. So
That's why when we want to invent something new, we've got to be good in maths, and maths is physics after all.
okay, actually, physics is applied maths. Physics theory works, but then we can't. Okay, physics help us understand the universe, but physics don't help us apply the universe. We apply the universe by using mathematical calculation in physics. Right.
What came first, physics or maths?
Knowledge must coexist together. No, there's nothing as which one comes first, because what comes first is
Later, I ask
philosophy.
you a question about how many universes there.
Okay, that's a very subjective question, depending on whether you believe in the parallel universes or not. I'm not gonna talk about that because no scientists have an answer to that. So, about
Not talking about Avengers, okay?
quiet. No, that's quantum physics actually. Okay, string theory and all that. Okay, I'm not gonna talk about that. So, what comes first is actually philosophy. Philosophy is the love of knowledge. Because humans are different from all animals, because humans, our brain, we want to know knowledge, and because we want to know knowledge, we discovered new knowledge. We discovered science, we discovered mathematics, we discovered social sciences, we discovered how humans think, what humans like. All that is because we want to know things. So that all came from philosophy. So which one came first? I'll say philosophy. All right, so now, okay, we've spent a lot of time introducing ourselves already, so let's continue lah. All right. So because today is the first class, I actually want to know each and every one of you. I want to know you. I want to build a relationship with you. Right? Don't just treat me as your teacher. You can treat me as your friend. I don't mind. You don't have to call me Mr. Benison. You can just call me Benison, Ben, Mr. Ben. I don't care. Call me whatever you want. I want to have a relationship with you. I want to help you love physics so that you'll be able to score an A in your SPM physics. All right? Is that cool?
Yes.
All right. So, physics, the high level, we don't compare physics with chemistry and biology. Chemistry, okay, see, not sure you can see my hands or not. So, this is biology. This is chemistry. Physics is up there. You can't compare them. They're not the same. Physics is for highly intellectual people. You can't compare like that. Don't tell your biology teacher. Don't tell your chemistry teacher. But that's the truth. Yeah. No, like actually based on first. I mean, some people may like biology more. Some people may like chemistry more. Because physics, I agree, physics is hard. Physics is hard. It's the hardest. But everything works because of physics. So physics is the more you study physics, the closer you are to understanding the truth of the universe. That's all I can say. All right. So let's take a look at resultant force on objects. Okay, resultant force on objects. Can you give me an example of when resultant force will? What are some examples of applications of resultant force? Anyone?
Everything.
Everything. Exactly everything. Example. Okay, let's say over here you have a surface. Okay, over here you have a surface. Let me use a different color. Over here you have a surface. Over here you have a surface, and over here you have an object on the surface. Okay, when you have an object on the surface, what will happen? This object will exert a force on the surface, right? Does that make sense? Because when you put, okay, let's say your hand is the surface, let's say I have my mouse here, you put something on your hand, you feel a force of this object pushing your hand down, right? Hey, look at me right now. Okay, look at me. Look at my hand. I put an object, okay, I put my mouse on my hand. I can feel the mouse pushing my hand downwards. Any object, okay, that has mass, you put it on a surface, it is actually exerting a force on the surface. Am I right?
Yes.
So
And-
what is the name of that force?
Weight.
Weight. Correct. Weight. Okay, we have a force called weight. But we all know that if there is a force, there must be an acceleration. So because there's a force acting, so theoretically, when you put anything on the ground, that object will continue to sink underground and continue to sink until it reaches the center of the earth. Am I right?
Yes.
That makes sense, right? Because it's putting a force on the surface of the earth. When you put a force on the surface of the earth, what will happen is that object will push the ground and sink to the center of the earth. But why will that not happen?
Because the material of the soil is harder than the
No.
object.
No. It's because when the weight is acting on the surface, okay, it's exerting a force downwards, right? But it is not moving because the resultant force is zero. Why is the resultant force zero? Why is the resultant force zero? Because Newton's third law of motion states that every action will have a reaction in the opposite direction with the same magnitude. So there is another force. The object, let's say the object is 50 Newton lah. Okay, 50 Newton. The weight is 50 Newton. The object push the ground with 50 Newton. The ground will push the object back with 50 Newtons. Okay, the ground will exert back another force, same magnitude to the object. What is the name of this force?
Gravitational force.
No. Gravitational force is this weight pulling it down. But then the ground will exert another force upwards, opposing the force of the weight, opposing the direction of the weight. This force is called the normal reaction. Remember this or not?
Normal reaction.
Yes, normal reaction. Okay, I want you to do something right now. You find the nearest wall to you, you push the wall. You push the wall. Are you able to make the wall move?
If I'm hooked, of course.
Right? You're not able to make the wall move, right? But are you adding a force onto the wall? You're pushing the wall with a force, right? You're exerting a force.
Yes.
But why the wall won't move? You're using a force to push the wall. The wall should move, right? According to theory. But why the wall will not move? It's because the wall will push back another force. You don't believe me? You try to punch the wall. Punch the wall.
That's the
You
result.
punch the wall. You punch the wall. When you punch the wall, you're using a force, you're acting a force on the wall. But why your hand feel pain?
Because there's resultant force.
Not resultant force. There's reaction force. There's a normal reaction force. You punch the wall 50 Newton. The wall say, you punch me, I give you back another force, 50 Newton. Then you feel the 50 Newton on your hand. Then you feel pain. So that is what's happening. Okay? You're not able to move the wall because whenever you can feel it yourself, when you push the wall, you can't push the wall because you feel that wall is giving you another force, pushing you back, right? You feel that, right? So that force is called the normal reaction. Whatever force, okay, you add any force on the surface, if the object is stationary, the surface will actually, it's because the surface will actually give back another force in the opposite direction of the same magnitude. So that is what we call as a normal reaction. Very normal is because it's perpendicular. Understand?
Oh wait. What happens if we punch a jelly?
You punch a what?
A jelly, like the soft thing. And
Yeah, you punch a jelly. The jelly will actually give you back another force, right? You can't, okay. Have you tried punching water? You go to swimming pool, you try to slap the water. You try to do that. You will feel pain, right?
Yeah.
Why? It's because the water gives you back a normal reaction. Does that make sense? Your hand, you try to slap the water, you realize your hand cannot go through the water. But when you slowly push your hand down, you can go through the water, right? When you try to slap the water very fast, your hand cannot go through the water. The water slap you back with a force, right? Does that make sense right now? Normal reaction makes sense to you, right?
Yes.
So see, physics is everywhere. Okay, so Now you understand what's normal reaction?
Yes.
Okay, very good. So let's say over here, you have an object move. Let's say you pull. Okay, let's say you pull the object in this direction. Okay. Okay, this is a pulling force. Okay, let me just write down the names of the force so that you are clear. Or else you don't know all these symbol, you don't know one. Okay, let me write down. This is weight. This is normal reaction. So let's say this is a pulling force. When you pull an object across a surface, what will happen? When surface are in contact and you pull the object across the surface, what will happen between the surface of the two objects?
Friction.
Friction. There will be a frictional force here. Friction. Okay, there will be friction. So this is resultant force. Okay. Resultant force is the total force. The total force acting on the object. Okay, if same direction, then you add them together. If opposite direction, you take the bigger one minus the smaller one, then that will be the resultant force. Resultant force is like the result, the total sum of the vector. Opposite direction, you put a negative. So the total sum, you plus the negative together, it becomes minus. That's why I say resultant force is the sum of all the vectors. Do you understand that?
Yes.
Yes, okay. I hope you really understand that. Okay, let's say let's say there's an inclined plane. Do you know what is an inclined plane?
What's an inclined plane?
Something like this lah. Okay, and then oops. Yeah, give me some time. Okay, we color this object.
Oh, this thing.
Okay, so if in physics, if the object is on the surface that is horizontal, no problem. Horizontal is very easy. But not every time in life everything is horizontal, right? The road is not always flat. When you want the path is not always flat. So when you want to move objects, you don't always move objects across a flat surface, right? I'm not talking like not flat lah, like not horizontal, not perfectly horizontal. You have to move an object upwards. Sometimes, like yeah, like there's a slope. Okay, let's say there's a slope. You want to move the object up the slope. So when that happens, things get tricky because there's an angle of inclination. Okay, this is called the angle of inclination. So incline means like that. Okay, incline means like that. Okay, plane means flat surface. So this is an inclined plane. Understand?
Understand.
Okay, so what are the forces acting on this object right now? Okay, let's say this object is sliding down. This object is sliding down. Sliding in that direction. What are the forces acting on this object? Tell me, just simply shoot out some. Just say any force that you think is logical. Hey, give me some answers. What forces do you think are acting on this object?
Is the object going down or up?
This you see the direction of my arrow. If the object is sliding downwards, what do you think is the are the forces acting on this object?
Weight.
Weight, exactly. Weight, what's the direction of weight?
Down.
Yes, down. Okay, downwards. Okay, this is weight. What other forces do you think? Okay, actually, okay, for this diagram, I want you to label 2 more forces. Okay, you don't have to draw anything lah. Okay, after I draw finish, you screenshot and you write it in your notes. So over here you have weight. This one also got weight, right? This one also got weight. So I'm just gonna write weight. Any object will have weight, and if it's on the weight acting on the surface, there must be a normal reaction. Okay, so you have weight in this diagram. What other forces are here?
We call this thing.
The what?
What's this thing called?
Huh? What was that?
It's kind of the clamp thing.
Huh? I don't know. Okay. All right. So the forces, okay, the forces acting on this object, okay, you have another force because it is acting a force. It is acting a force in this direction too, right? It's always acting a force parallel, a perpendicular surface. So there must be a normal reaction. So the normal reaction will be in this direction, perpendicular to the surface. Normal reaction. Okay, other than normal reaction, when the thing is sliding down, do you think that's friction?
Yes.
Yes, that's friction. So friction will be between the surface. So this is friction. So these are all the forces acting on this object. Okay? Can, right? Okay. What if instead of sliding down, what if you pull the object upwards? Because you don't need to pull the object will slide down naturally. But what if you add a force? Let's say you're during primary school, or don't need primary school lah. Primary school you got the bag that it's like a trolley on. Yeah. Okay. School bag that's like a trolley. So let's say you want to go on a vacation. You're pulling your luggage. Your luggage got wheels. And then you're pulling your luggage upwards on a slope or on an inclined plane like this. Okay, let's say you are, wait, let me draw finish. the object. So what if you pull the object in this direction? That's big. Okay, this will be your pulling force. You pull the object in this direction. What are the forces acting on this object? Come on, give me some answers, some responses. Hey, come on. Any answer? What are the forces acting on this object?
Sliding force.
No. Sliding is not force. Sliding is not force. Okay. That's why you see, I never draw this arrow attached to this object at all. I'm just showing that this is the direction of the motion sliding. But now you're adding a force, you're pulling force, you pull upwards. Okay. Kai Huang say friction. Yes. Hey, you can unmute now, but okay, you sure you can type in the chat if you want. As long as you type in the chat, everyone can see. Okay, friction. Correct. There will be friction. What is the direction of the friction, Kai Huang? What's the direction of the friction?
Same as the pulling force.
No, friction will always be in the opposite direction of the motion, right? You learned that in primary school, right? Friction will always be in the opposite direction of the motion of the object. So friction will be here, in the opposite direction. You pull upwards, friction go down. This will be your friction. Okay, what other forces are acting on this object?
Is there weight?
Yes, there is weight. You have weight. Okay, what else? What else? Other than weight, what other forces do we have? Zekai, do you want to give me an answer? Wait, what about Philotis? What other forces are acting on this object?
Is there a normal reaction here too?
Yes, there is a normal reaction. Any object that is exerting a force on a surface will always give back a normal reaction. So the normal reaction will be, what's the direction of the normal reaction? Do you know? Can anyone tell me what's the direction of a normal reaction?
Is it upwards?
No, it's not upwards, but it is perpendicular to the surface. Upwards means like that, no, right? Opposite direction of weight. No, it's not really upwards. It's not in the opposite direction of the weight, but it is perpendicular to the surface of the inclined plane. So this will be your normal reaction. Okay. All right. So I want all of you to take a screenshot. Okay, take a screenshot. Okay, have your screenshot?
Yeah.
Okay. All right. So all of you take a screenshot already.
Yeah.
So okay, tell me, did you all screenshot for the resultant force?
No.
Which part of the resultant force?
No.
No, you did not. Zekai, you did not screenshot.
Yeah,
I
because
say,
I'm afraid I screenshot a handsome boy here.
huh? What?
I'm afraid I screenshot a handsome boy here.
I asked you all to screenshot because I will not be doing the same thing next week. Okay, that's why I asked you
Yeah,
to screenshot because you will be
never mind,
receiving
never
your
mind, never mind.
next week. No, it's not okay.
We'll
You'll be
have
receiving-
replay, ma.
Oh, you okay? You're gonna watch the replay, lah.
Yeah lah, we have replay, ma, not lah.
I mean, like, what for you?
It
want to
just
watch?
blur. Oh,
What?
oh.
I mean, I know there's replay, but what for you want to watch again? Okay, lah. You watch the replay.
I can
you-
watch again to screenshot, ma, not lah.
Okay, okay. So you're gonna fast forward, lah, right?
Not lah.
Or if you don't understand, yeah, feel free to watch the replay 10 times, 100 times. Watch until you understand. Any questions, you have my number, you PM me. Right? I'm in the group, so you PM me. Okay, so, okay, right? Everything about resultant force over here.
Well, touch your hands on.
Okay, yeah, no more questions, right? For resultant force.
No more.
Okay, I think. All right, so that's it for today. Remember to, after you get your notes, your hard copy notes, remember to copy it in the notes. Is that okay? Can,
Yeah.
Okay. All right, so let's end our lesson right here today. Right. I hope you enjoyed the lesson. All right.
Well,
And-
remove my background first. Later she.
Okay, I hope you enjoy the lesson. All right, I'll see you next week. If you have any questions about physics, your school homework, or while you're doing your revision, you don't understand, feel free to ask me anytime. All right, see you next week. And if you have any questions, you can stay back right now and ask me. All right, I'll stop the recording. Thank you.
Oh, I will never leave one.